All right, this video is going to cover 1.5, which is composition of functions. Basically, you use composition of functions to make sure that two functions are inverses of each other, okay? And this right here gets a little confusing. I think it's a lot easier to just see this graphically, algebraically. So we're going to jump straight to 1 through 4. All right, so let me show you how to do this. Basically, what they're wanting you to do when they say this, f of x is this one. F negative 1 is like y prime, okay? So just clarifying there. They want you to take y prime, this equation, and plug it in for letter x of the original equation. So let me show you what I mean. Nothing else changes. The 2 doesn't change. The letter x becomes parentheses, and then this equation right here, 1/2 x plus 1. And then you still have your minus 2 at the end. So literally only the letter x changed. All right, now you just need to solve this a little bit. So we're going to distribute. Okay, we're going to distribute here. 2 times 1/2 is 1. So you distribute, and then you just go solve. So this plus 2 minus 2 is going to cancel, and you're left with y equals x, or f of x equals x. And if you get x, that's a good thing. It means these were inverses of each other. If I ended up with like 2x or x plus 1, that's a problem. That means they would not be inverses. All right, so let me show you another one. Take your inverse equation, plug it in for the letter x here. Use parentheses. Okay, just like that. Now do a little algebra here and distribute. -3 times -1/3 is +1. -3 times 4/3 is -4. So you end up here, the -4 and +4 cancel, and you end up with y equals x. Okay, let's look at another. Take this equation, plug it in for the letter x. Okay, now do some algebra, distribute. 2/3 times 3/2 is 1. 2/3 times 6 is 4. +4 minus 4 cancel. You end up with y equals x. And then this last one. And then on this one, the +5 minus 5, just go ahead and cancel right there. I think my batteries in my pen are running out of juice. Okay, so that's how you do composition of functions right there. All right, let's keep moving. Look at number 5. They want you to prove that these are inverses of each other. So G is on the inside here. And so you're going to take G and input it for x into f of x. So it's going to look like this. Same process. Okay, now you're still going to distribute just like before. 3/4 times 4/3 is 1. 3/4 times 8 is 6. Then cancel the +6 minus 6. So these are inverses of each other. Let's look at the next one. Sometimes they write it like this. Sometimes they write it like this. It's the same thing. It doesn't matter which way you write it. G is still on the inside. So that means G of X here is going to get inputted. And so it'd look like this. Okay. Now you're going to distribute. Now look at this one. The +3 and -1 are not going to cancel. When that happens, so like we end up with x plus 2. That is not x. That is not just x. So no, these are not inverses of each other. So that's what it looks like when they're not inverses. Okay, let's keep moving. This next page, they want you to solve. I'm not going to do the composition on this page because I just showed you how to do it, but they want you to solve for specific letters, G. So this is important to be able to do. So we need to get G equals. All right, so in this one, you have Y equals F plus G over 3. The first thing you would do is cancel the 3 by timesing by 3. So now you got 3y equals f plus g. And the last thing to do here to isolate the g is to subtract f. So this one would be g is equal to 3y minus f, just like that. Okay, this next one, they want you to solve for h. So my first move here would be to cancel that 1/2 by timesing by the reciprocal, which is 2 over 1. You could just put 2 if you want, it doesn't matter. So now you're at 2a, 2, okay, come on. 2a equals bh. All right, and they want you to solve for this h. So now you got to get rid of that b by dividing by b. So you'd end up with h equals 2a over b. Okay, and then this last one, they want you to solve for w. Some people distribute here. I don't. I just cancel the 2 by dividing by 2. So you got p over 2 equals l plus w, and they want w, so subtract l. So you get w equals p over 2 minus l. So that's how you do those. But yeah, composition of functions, basically just plug one equation into the other and do a little algebra and see if you end up with y equals x. And that's how you know they're inverses. Hope this video helped.